Hi, welcome to Making the Space. My name is Pat Schuff. We will be working on a relatively simple project as part of our welding series. We're going to start out with a simple wooden two-step to go up into a building. It's a rental property that we're looking at. Alternatives are buying prefab steps, buying prefab cement, or building one with steel. We'll look at the requirements, the cost, the city regulations, and walk through building two of these steps to go into a rental property. First, let's look at the design requirements. We have a one-story building that is slightly raised with pier and beam off the ground and needs a step to get into the front door. Relatively simple. It's about a 15-inch rise, 16-inch rise, and the stairs can be dropped and a cement pad put underneath. We also have a second two-story unit that has a front door with a similar elevation with pier and beam blocking. And this gives us a chance to build two different steps with two different designs, so we can compare and contrast the effort, the cost, and the long-term support and viability of each step design. If I hired a contractor, they would put together a very simple solution using 2x12s for the risers and 2x10s for the steps. This is simple, it's easy, it can be done or it can be purchased. We'll look at that as the first option. If we look at a traditional big box store, they sell two-step stringers or three-step stringers or larger at about $20 per stringer. You need 3 of them. So $60 for the base foundation plus $25 for the 2x10 that will stretch across it. We can find a cheaper solution at a local hardware store for $9 per stringer for a two-step, thus dropping our price below $50 or right around $50 to solve this problem. So alternatives to building it all out of wood is using a prefab metal or cement. Prefab metal comes in at about $110 for a two-step. And then cement comes in a little above $300, which is pretty cost prohibitive. So before we get too far along with any design or decision making, we need to look at the local requirements. For a stair, we need at least a 7 3/4 inch rise and a 10-inch depth on a step. This is assuming it's new construction as opposed to repair of an old staircase. To be honest, it's confusing. I'm going with the new construction 7 3/4 rise with a 10-inch tread depth for the step. If we were doing this from scratch, we could go to calculator.net and calculate the angle and rise and run and everything needed to create the steps using a 2x12, which is about the same price as buying the stringers at $9 each. A 2x12 would cost about $30. 3 stringers cost $30. So it's cheaper to buy the stringers and not have to cut them out using calculations to figure out how to cut them. So basically, I went and got some prefabbed stair steps, which will be installed at this angle. It has a 10-inch depth and a 7.5-inch rise with a 2-inch board on top. I have cut some 2x12 pieces of wood that is pressure treated so that it should work perfectly fine. And we're going to screw this together. It should take some exterior screws, which we've got some standard 2-inch exterior screws, which given that this height is 1 inch and a bit more, that'll give us a 1/2 inch of screw into the wood, and we'll drill it a little further in. So this should work pretty well. Overall cost, the risers were about $11 each. The 2x12 was about $9 for an 8-foot section. I cut 2 37-inch lengths, and then this is what's left over from that. So each, we're looking at 33 plus about $40 The screws were about $10 for a jar of 150. We're not going to use nearly that much, but overall the project is about $50, which is about what it cost us for the steel. Building the wooden steps was relatively trivial. We took a 2x10 board, cut it in two places, and that gave us the two steps. We needed some screws, and then just pre-drilled the holes, then screwed in the screws. Okay, overall this took about 10 minutes. It's not perfect. It's not going to last long. I can pretty much tell that. I've got a feeling that this is going to be a bit warped, that it's going to work fine for a year or two, and I'll probably have to replace it. So overall, cheap, easy. If I were a contractor and I'm building 20 of these, I'd do it this way. So I can't actually finish the installation because we're on a permit hold. I need to put siding up, and then I can screw the back of the step into the foundation of the house. From different angles, different perspectives, it's going to work. I need to put some cement slab down. I've got plenty of cement bricks that I can use as a foundation to keep it stable and level. So to compare and contrast, the next set we're going to build is a steel frame with wood inserts. We have to go through and design two sides and then stretchers to stretch between the two. A step width has to be at least 35 inches, which is what we've got here for the design. For the design, we use Fusion 360 because I want to practice with it, and this is a relatively simple design. It will give us our cut list for the steel. We're going to use 3/4 inch square tubular steel to create everything and create a solid insert so there are no air holes or gaps. One of the nice things about Fusion 360 is we can go in and put a parameter list in and scale this. We can make the steps wider, we can make them taller, we can make them deeper just by going in and defining step depth and step width and step height. It allows us to parameterize everything and not have to go in and define everything very specifically. The beauty of using a CAD program to lay out the design is we can go each piece by piece, look at the angles of the cut, look at the length of the steel requirements, and then calculate exactly how much steel we need for the final design. Overall, this was pretty simple. It didn't require that much steel. Basically, we purchased two pieces of 3/4 inch square tubular steel at about $40. So starting another project today, building a couple steps going into a property. And that begins with stopping at Texas Iron and Steel to pick up some metal. It's a busy day. There's a lot of people here picking stuff up. Okay, we've got 6 pieces of steel, 3/4 inch by 3/4 inch, cut to 8 feet long. Total price was $54. This is a lot cheaper than going to Lowe's and buying preformed pieces at $25 each. So hopefully we can make this cheaper from scratch steel. We've got 2 steps we're building. One is a 15-inch riser and the other is a 16.5-inch riser, where this is the riser height, and it's got a constant depth of 20.75 inches. So no big deal on getting this done. It should be pretty simple. We're taking a bunch of 3/4 inch 16 gauge steel and cutting it up into the different segments. And notice the angled cuts on each of the 2 segments, and then the different cuts that happen on these segments. So I have to be real careful with the cut list. I did a quick list of what's needed. I'm probably going to do one less of the back, so I'm not putting a bar across the bottom back. Try to save a little steel. The equipment I need to make this happen: a pair of gloves, welding mask, grinder, diagonal cutters, measuring tape, some soapstone, a wrench, and a chop saw. And then along with that is a MIG welder. Relatively simple, relatively easy. We're going to start this project and see if we can finish it in less than 2 hours. So I should have known that 2 hours was a pipe dream. I'm not sure what I was thinking while I was in the lab. It took about 30 minutes to cut all the steel with the angles, with the right shapes, right size, grind it down, get it nice and clean. And then I could start welding everything together. Welding took a lot longer, and then having to post-grind things down and put the stretchers in was a bit of a problem. Unfortunately, I didn't get video of putting the stretchers in and had to go to the wood shop, get some pipe clamps to pull the steel back together so that it would weld a whole lot easier. So prior to welding, I dry fit everything together to make sure things were square, things worked out properly, and I noticed I had made a small mistake in my design, and one of the pieces was 3/4 inch too long. Had to go back and cut it, but once I had cut it, corrected, everything was square, everything was symmetrical between the two pieces, and I was able to prep for welding. One of the key preparations for prior to welding is to grind the coating that's on the steel tubing off, because the MIG welder doesn't do very well with the coating. It causes some bubbles, it causes some issues. So grinding each angle, grinding each corner, grinding the ends off a little bit helps substantially in getting a nice square fit. Using the metal angle brackets also allows me to get a nice 90-degree, and I could start by welding certain corners, rotating, doing other corners, and it worked out relatively well. I started by welding the base corners because those are the foundational pieces. Everything needs to be square from the bottom up. So making sure I've got a 90-degree angle from the bottom to the back and the bottom to the front is critical to get everything in square and plumbed. Once I finished welding one side, I flipped it over, made sure the other side was relatively smooth, and did grinding between to make sure it laid flat on the surface of the table. Once I had two sides of the square finished, I rotated and worked on the first step to make sure it was square with the base. From there, I was able to make sure that the riser for the second step and the flat part for the first step was at a 90-degree and everything squared up appropriately. Having a large number of clamps allowing me to clamp it at different angles and work on the piece from different perspectives helped substantially. Using the 90-degree magnets, I was able to prop things up, get them in the right orientation, and make sure that I had a solid seam at the 45-degree angle from the front, back, sides, and inside angle. Hopefully at this point everything is square, so the last riser and the top step should be a 90-degree angle. If not, I've got to bend things a little bit, stress things a little bit to make sure it is a perfect fit. Worst case, you don't want a step sloping up or down. You'd like to have it as flat as possible. And using a level at this point to make sure everything is level and square, and using a T-square and a architect square helps make everything exactly the way you want it. Once both sides were done, it was a matter of cutting the step pieces, which will join the two sides together, grinding the ends down, and then welding them to the sides. This turned out to be relatively simple. It was not anything that caused issues or problems. It went in relatively easy with the exception of the middle one. I didn't get footage of it, but I did have to get a pipe clamp to pull everything together because the internal bowed out just a tiny bit, and I had to pull it together so I could weld it and get it to stick appropriately. The last step was to use the bandsaw to cut some angle iron, some 3/4 inch by 3/4 inch L brackets, so that the wood will rest appropriately on the gap between all of the steel. The idea is I get a 2x10 trim it down to the appropriate length, trim it down to the appropriate width, slot it into the steel, and it rides on the L brackets that are welded to the bottom of the steel. The last and final step to finish this off was to grind everything down, get the patina off the steel, and then spray paint it. It took 3 coatings of spray paint, 1 can at about $10 to get everything covered, coated, and appropriately ready for external use. So once the paint dried after 3 coats of paint, I took it into the wood shop, took the treated 1x10 or 2x10 and cut it to length, and then used the bandsaw to cut width. The width is not quite uniform. It does bow a little bit, so I wanted to fit the wood into the steel cavity as much as possible. So using the table saw would have worked, but it would have left some gaps. So using a bandsaw allowed me to highlight the profile, get everything to ride in, and get everything to snugly fit. So overall, I'm pretty happy with the steel and wood combination. The basic cost came out to about $85 for a finished product, including the steel, which I have excess of, a 2x10, which I also have excess of, and $10 of spray paint to make sure it doesn't rust sitting outside. Sitting in front of the 1-story building that we're putting this into looks perfectly fine. I need to put some cement blocks down, but again, we're waiting on permits so I can fix it to the siding that is going to be put in, and then dig a small hole to put cement blocks into. And with that, we can compare and contrast the time, the cost, and the effort to do all 3 different variations. So for the wooden step solution, we're looking at a total cost of about $65 and a time to build of about 20 minutes. It took longer to go to the hardware store, buy the materials, than it did to actually build this. Doing the steel didn't take a whole lot more money. It was $20 more expensive than the wood, but it took substantially more time, 20 minutes compared to 4 hours, with most of that time as welding time and grinding time, and a lot of extra time for paint because I had to let the paint dry, come back, paint it a second time, let it dry, come back a third time, let it dry. So overall, it took 2 days to finish this project because I had to let things dry overnight so that we got a good finish on everything. In the end, I like it better. It has better aesthetics. It's going to last longer. I'm not going to have to repair it in 3 to 4 years. I would do it again with the steel just because it's a higher quality.
And now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.